So in this video, we're going to talk about scientific notation. It is a method for us to write very big numbers or very small numbers. So for example, the diameter of an atom is 0.00000000005 meters, which is very tedious for us to say so many zeros, and also when we say that, people will not remember how many zeros we have said, and so it will probably we make mistakes if we miss a zero. We actually added an extra zero and things like that. So it's just tedious to write down so many zeros. So we try to figure out an easy way to write it so we won't have to write down so many zeros, number one. Number two, it will help us avoid mistakes. And notice that this number can be written as 5 times 10 to the negative 10, and we call 10 to the negative 10 a nanometer. And so we could just say 5 nanometers. So the rule for us to write this number, and notice that this notation here, first of all, is that we don't need to count how many zeros we need to write down. We just need to remember the negative exponent, which is negative 10. So in order to help us understand why this can be written as 10 to negative 5 times 10 to negative 10, we're going to look at the exponents of 10. So for positive exponents, I think we are familiar with this. 10 to the first is 10, and 10 to the second is 10 times 10, which is 100, and 10 to the third is 1000 because we have 10 times 10 times 10. And notice that the number of zeros match the exponent. So if we have one copy of 10, we got 1 0. If we have two copies, the exponent is 2, we have 2 zeros, and so on. So these are, we're going to use these to record very big numbers. So for example, if we have a huge number like 10, I'm going to just add a bunch of zeros like this. So when we use the exponent notation, we don't have to write so many zeros. And the exponent, remember, the exponent is the same as how many zeros we have. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So we can write it as this number as 10 to the 8th. So again, writing down 10 to the 8th is much quicker and easier than writing down a number with so many zeros. Okay, so let's look at negative exponent. We just talked about the inverse, the negative exponents, which means the inverse of or the reciprocal of the base. So in this case, it means we flip 10 to get a 1 over 10. And we know 1 over 10 can be converted to a decimal, which is 0.1, 1/10, which is the same as 0.1. And in order to simplify 10 to the negative second, so first we can do 10 squared. We know 10 squared is 100. But then we're going to have to flip because of the negative x sign. We're going to have to flip 100 to the bottom to get 1 over 100. We know that can be converted to a decimal of 0.01. And you can either do long division here to get a decimal, or the quick way to remember is whenever we divide a number by 10, we move the decimal point 1 place to the left. If you divide by 100, 2 places to the left. All right, or you could do long division to get that. And from the place value of numbers, we also know a tenth, 1/10 means the place value. So let's say if I have 1.2345 and 2/10 means 0.2. So, okay, now let's look at 10 to negative 3, same thing. And we're going to have, first of all, do 10 to the third. That gives us 1,000. The negative sign means we have to flip it to the bottom, 1,000 to the bottom, and that gives us 0.001. So here, let's look at or find a pattern between the exponents and how many decimal places to the right of the decimal point. So notice that if we have the exponent is negative 1, the 1, and that matches the number of decimal places to the right. of the decimal point. So -2, we have 1, 2, 2 decimal places. -3, we got 1, 2, 3. So that would be a little easy for us when, let's say, if I have 10 to the -6, and to convert it to decimal, we know we should have 6 decimal places. So we're going to write on 1, 2, 3, 4, and 5, and last digit will be 1, so 6, and will be 0.000001. Now, to go backwards, that's what we need to do. So if we are given, for example, let's go back to look at the diameter of atom. So if we're given something like this small, well, 5, we're going to have to deal with that in a second. So first, I'm going to actually just going to use, let's say, 1. I need 10 decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If, let me change it to 1, and then we're going to figure out how, if it's 5, what we're going to do. Okay, so 0.00, again, 1, and notice that if we count the number of decimal places, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And from what we just observed, and we should, if we have the number of decimal places matches with the negative exponent, the positive number in the negative exponent. So that tells us I should have 10 to the -10. Okay. Well, if it's not 1, if it's 5, and noticed this number, if it's 5, it's 5 times, the number will be 5 times this digit, just like point 5 would be 5 times 0.1, 5, and if it's 0.05, it would be 5 times 0.01. So if and when you look at these two very small numbers, and we can obtain the top one from the bottom by times 5, because it's 5 times literally. So that's why we have this for the diameter of atom, we have a 5 times in front of it, because we do have a 5, we don't have a 1 there. Okay, so now let's look at some examples here. If we have a huge number, so here I have a huge number and a very small number. So when we have huge numbers, notice it's going to be, when you have a huge number, the exponent is going to be positive, and the exponent matches the number of zeros, or decimal, how many decimal places. So this is what we're going to do. And actually, for scientific notation, we do have a rule and we need to remember. And so, for example, we can say this number is 1, 2, 3, 4, 5, 6 times 100 times 100, and then 100 can be written as 10 squared. So we would be writing the number as 10 squared, and which is not really much easier. And maybe somebody will want to put a different exponents. Say they want to just say this times 10. Maybe they can do 1, 2, 3, 4, 5, 6, 0 times 10. If we just use one decimal place. So different people will have different exponents. So here in order to make sure everybody use the same scientific notation, so here's the rule. The number, so we can write the number as something times 10 to some exponent. And the number here has to be a number between 1 and 10. It can be equal to 1. I'm going to use the internal rotation, but it has to be less than 10. So if I stop right here, I got this huge number, 123,000, which is not a number between 1 and 10. So that's not the scientific notation. So what we're going to do is we're going to start from the very end of the number, and we put a decimal point here, and we're going to move the decimal point to the left until we reach a number between 1 and 10. So we're going to keep going 1 time, 2 times, 3, 4, 5, 6, 7. So when we get here, we know I can stop because I get a number 1.23456. Anyway, this number is between 1 and 10. And if I stop after 12, and that is a number bigger than 10, that's not going to work. That doesn't satisfy our agreement. But if I move 1 over, I get 0.12, and again, that's less than 1, and we don't want that either. So if we have this agreement, everybody will have the same scientific notation. So first of all, you can write down the number 1.23456. Now, if the rest of digits are not important, you could just round it to 1.23 or just 1.2. And now let's figure out this exponent. The exponent is this going to be the same as the number of times we move the decimal point. So 1, 2, 3, 4, 5, 6, 7. So this is going to be 10 to the 7th. Again, the reason is if we have 7, exponent is 7, you're going to have 7 zeros. And notice this is literally saying 1.23456 times 1, 2, 3, 4, 5, 6, 7. It's like multiplying 1 point something and 10 million, and which will, of course, will give us this 10, around 10 million or 12 million. So whenever we multiply a number by 7 zeros, it's equivalent to shifting decimal point back 7 times, which will go back to the number we have. So if we move the decimal point back 7 times, sorry, so that would go back to the original number. So that's why this scientific notation, this is the same number as that. Okay. Now, so to summarize, how do we turn this number to to its scientific notation? So first we're gonna put a decimal point in the end, because for whole numbers we don't really see a decimal point. And then you start counting how many times you're gonna get a move. You have to move the decimal point, so you can get a number between 1 and 10. So you write down that number and then times 10 to some exponent, and next exponent is how many times you move the decimal point. And for very small numbers, we go backwards. So we're gonna have, because the number is small, and we also want to, we have to move the decimal point to the right in order to reach a number between 1 and 10. So notice that I moved 1, 2, 3, 4 times. And so I write down, I reached the number 1.234, and that's a number between 1 and 10. And times 10 to the negative exponent 4, because I moved it to the right 4 times. So for a huge number, you will use a positive exponent, because that's going to make this number bigger to go back to the big number. But if you have a small number, because since we increase the number, so you have to times very small decimal right here, and times negative 4, that means you move the decimal point back to a small number. So again, how many times you move, so this is moved to the left. That's the number of times we move the decimal point to the left to reach this number. And negative 4, that 4 is the number of times we move the decimal point to the right.